let me ask you guys a question. How can you put this water balloon inside this bottle? Well, I know what you guys are thinking because that's what I used to think earlier too. You can squeeze a balloon, you can squish a water balloon, see? So, you can squeeze it inside like this. Well, let's give it a go. Do you see anything happening? Nothing's happening. Well, that's not the answer. Let's try again. Newsflash, that's not working. The answer to that question involves air. And to get to the answer, we're going to have to explore air. And that exploration of air begins with just a bottle and a balloon. Let's dive in and see what we can find out. So, it all starts with a simple balloon and plastic bottle. Any plastic bottle will do as long as it does not have any holes except for the top. So, we take the balloon and we put it inside the bottle's opening. Then we take this part of the balloon, the mouth of the balloon, and stretch it over the cap at the top, like this. Let's get ready to explore air. Well, you might ask, where is the air? Well, air is all around us. I have air all around me, pushing down on me, even air inside this bottle. Even though air may be invisible, it's still there. It's still matter, and it takes up space like all matter does. This table is matter, it takes up space. I'm matter, you're matter. We take up space. So, there's matter inside this bottle. So what will happen if I try to blow up this bottle? Well, let's find out. Well, it won't be that difficult. I can just take one balloon over here and blow it up. And that means I'll be adding air into this balloon. That wasn't too difficult. Now let's see if I can blow up this balloon inside this bottle and blow even more air inside. Because when you blow up a balloon, you'll blow air inside. But this bottle already has air inside. So what will happen if I blow this balloon and add even more air into this bottle? I'm not faking or kidding. I really can't do it. Trust me, it won't work. But why is that so? Because like I've explained earlier, there's already air currently inside this bottle. So, when I try to add even more air into this balloon, the air inside here is already filled and packed with air. So, when I blow it up, it simply can't expand even more because air is matter. It takes up space. So this whole bottle is filled with air that takes up the space inside it. Now, to test this air theory out, I'm going to do the exact same thing I did right here, but with another bottle. And there's only one thing different. And no, it's not the shape or size or anything. Let's see if you can find out what the difference is. Okay, so just like before, I put the balloon here and stretch the opening to the top and make it even, like this. Now, I've already placed one of these balloons inside of this bottle, and watch what happens when I add even more air into this bottle. Like we've covered earlier, air is matter and it takes up space. So if that's true, there should already be air filling this bottle just like this one. I wasn't able to blow up this bottle, but let's see what happens when I blow this one. I was able to do it, but why? Why was I able to add more air into this bottle? Didn't I already explain to you earlier that air is matter and it takes up space? But why was I able to add more air from this balloon into this bottle? Can you guys find out? Well, if you guys can't find out, there's a clue. Now, I'm going to blow up this bottle 2 more times and let's see if you can find out that clue. Did you guys find it? Well, if you listen closely, it sounds like air is rushing out of the bottle. Do you hear that? That's the sound of air rushing out of somewhere. Guess what? Air actually was rushing out of somewhere. And if you don't believe it, look closely. There was a hole in this bottle. Right there. Do you see it? How in the world did this tiny hole, barely the size of my thumb, affect this whole process? Well, the answer to that is pretty simple. When I blew this balloon, the air that was already inside this bottle got pushed by the balloon out of the bottle from this small hole. I'm going to show you that air actually does rush out of this small hole using this bottle and an empty one here. Okay, so I have the empty bottle. I put it here. Look at the hole. I align it with the bottle and I'll blow. Did you see that? It fell off the table just because the air got pushed and forced out of this hole, and that air pushed the bottle off the table. So there was no air trapped inside the bottle like this one. No air can come out of anywhere. But in this bottle, there's a hole where the air can escape. Now let's dig deeper into the science of air. Let's repeat the same exact experiment with one little change. I'm going to blow this balloon up, covering the hole, and let's see what happens. Do you see that? The balloon stays blown up. Look at the top. There's an empty hole. I can put my finger in it, but the air isn't rushing out. Why is that? See, I have this green marker here. I can put it inside the balloon, but there's no air rushing out. Well, the reason is that this hole allowed air to move in and out. So, since I blocked the hole, air cannot move out anymore. So the air inside here won't come out. Like I said earlier, this hole allowed air to move out as well as in. So, if air cannot go out, then the balloon would stay blown up. And if it can't go in, then the air from outside all around us can't go in this hole and push the air from, goes in the bottle, then pushes the balloon, and the bottle will deflate. But when I let my finger out of this hole, that can happen because air will be able to go inside the hole. Did you see that? I'm going to show you guys that again. Did you hear the air coming out, rushing out of this bottle? I sure did. Now, doing this blows up the balloon when you blow from the top, but let's see if the same thing happens when you blow from this part. Well, we can't really blow or it'll turn to a disaster. See that? The total opposite thing happened from when we blow from the top. Let's try sucking in the air from this piece and see what happens. Commercial break. See? the exact same thing happened from when you blew from this part. Do you know why? Earlier, when we blew from here, the air from this balloon blowing up pushed the air out of this hole. The exact same thing is happening in reverse. When I suck the air from here, from up here, the air from outside around us is getting sucked in here, which causes this balloon to be pushed and it will blow up. And when I put my hand on this, it will stop the process because the air is currently getting pushed downwards, not upwards. If you guys remember at the start of the video, before we started exploring air, I asked you guys a question. How do you put a water balloon inside a bottle? Well, this experiment of air leads you to the answer. I have this bottle, I'm covering the hole so it stays blown up. And I have this bottle, it's no hole, and it's filled with water. Now I'm going to pour it inside this balloon. Not yet. Whoops. Yeah, that's good enough. Now, I'm going to get some of the help from my mummy to take this balloon out and tie it. Now that I've put water in this balloon, can you hear this? That's the sound of water, rushing water. So, this is how you get a balloon inside a bottle. As what happened throughout the video, we saw that air is matter and it takes up space. When I put the balloon in here and blew it up, when there was no hole, I couldn't blow it up because the balloon was already filled with air. But when there was a hole and I tried to blow, it blew up because this hole allowed the balloon to push air out of this hole. So as a summary, we have learned that air is matter and it definitely takes up space. Bye.